And we have one last one here that we want to look at. Which one do you think it is? Yeah, it's going to be an A minus a B times an A minus a B, or A minus B squared. And maybe I could put that out here too. That might have been helpful, since those represent the same thing. So, what do you think this pattern will be? Well, it follows exactly like the one before it, except there's going to be a minus middle terms, minus 2 ABs plus the B squared. So if you recognize something as A minus B times A minus B squared is A minus B times A minus B, follows that particular pattern. So let's look at a couple examples and play this out. So x minus 4 squared. I notice it follows this pattern, obviously because we're trying to create an example of showing you how this works. So it's first term squared, which is the A. So it's going to be an x squared minus 2 times the first term, x, times the last term, which is a 4, plus the last term squared. Work that out. X squared minus 8x plus 16. Again, it's a perfect squared trinomial, which means it results from a binomial squared. X minus 4 times x minus 4 produces that. Again, you can use FOIL in this particular method if you want. That's completely fine. You could stack x minus 4 on top of x minus 4 and multiply vertically. That's fine as well. But I hope after a while you start to recognize that of all the binomials we want to multiply, some of them follow in patterns. And if we can identify those patterns, well, let's use those patterns to our benefit. One last example. 7x minus 3. Let's square that. First term squared, which is a 7x. I want to square that entire term. Be careful of that. Minus 2 times the first term times the last term plus the last term squared. That's all there is to it. Now we just got a little bit of cleanup work to do. 7x squared. This 2 does distribute over the 7 and the x because it's 7 times x, it's a multiplication, which makes it 49x squared minus 2 times 7 times 3, 42, plus a 9. And there's my result. So how does that feel? Do you have to memorize these? No. You can always multiply old school. But I hope after a while, with enough practice, you start to recognize these, and then through the process of doing them, you learn them not through memorization, but just from their practical everyday use.